Sharks are a group of elasmobranch fish characterized by a cartilaginous skeleton, 5 to 7 gill slits on the sides of the head, and pectoral fins that are not fused to the head. Modern sharks are classified within the clade Selachimorpha and are the sister group to the rays. However, the term shark has also been used to refer to extinct members of the subclass Elasmobranchi, which are technically outside the Selachimorpha clade. Notable examples of improper classification include Cladozooloch, and various other members of the Chondrichthyes class like the holocephalid Eugendontidans. Under this broader definition, the earliest known sharks date back to more than 420 million years ago. Acanthodians are often referred to as spiny sharks, though they are not part of Chondrichthyes proper. They are a paraphyletic assemblage leading to cartilaginous fish as a whole. Since then, sharks have diversified into over 500 species. They range in size from the small dwarf lantern shark, Edmopterus perry, a deep-sea species that is only 17 centimeters, 6.7 in length, to the whale shark, Rhynchodentypus, the largest fish in the world, which reaches approximately 12 meters, 40 feet, in length. Sharks are found in all seas and are common to depths up to 2,000 meters, 6,600 feet. They generally do not live in freshwater, although there are a few known exceptions, such as the bull shark and the river shark, which can be found in both seawater and freshwater. Sharks have a covering of dermal denticles that protects their skin from damage and parasites in addition to improving their fluid dynamics. They have numerous sets of replaceable teeth. Several species are apex predators, which are organisms that are at the top of their food chain. Select examples include the tiger shark, blue shark, great white shark, mako shark, thresher shark, and hammerhead shark. Sharks are caught by humans for shark meat or shark fin soup. Many shark populations are threatened by human activities. Since 1970, shark populations have been reduced by 71%, mostly from overfishing. Evidence for the existence of shark-like chondrichthyans dates from the Ordovician period, 450–420 million years ago, before land vertebrates existed and before a variety of plants had colonized the continents. Only scales have been recovered from the first supposed elasmobranchians, and not all paleontologists agree that these are from true sharks, suspecting that these scales are actually those of Thelodont agnathans. The oldest generally accepted shark scales are from about 420 million years ago, in the Silurian period. Those animals looked very different from modern sharks. At this time, the most common shark tooth is the cladodont, a style of thin tooth with 3 tines like a trident, apparently to help catch fish. The majority of modern sharks can be traced back to around 100 million years ago. Most fossils are of teeth, often in large numbers. Partial skeletons and even complete fossilized remains have been discovered. Estimates suggest that sharks grow tens of thousands of teeth over a lifetime, which explains the abundant fossils. The teeth consist of easily fossilized calcium phosphate, and apatite. When a shark dies, the decomposing skeleton breaks up, scattering the apatite prisms. Preservation requires rapid burial in bottom sediments. Among the most ancient and primitive shark-like fish is Cladozooloch, from about 370 million years ago, which has been found within Paleozoic strata in Ohio, Kentucky, and Tennessee. At that point in Earth's history, these rocks made up the soft bottom sediments of a large, shallow ocean, which stretched across much of North America. Cladozooloch was only about 1 meter, 3.3 feet, long with stiff triangular fins and slender jaws. Its teeth had several pointed cusps, which wore down from use. From the small number of teeth found together, it is most likely that Cladozooloch did not replace its teeth as regularly as modern sharks. Its caudal fins had a similar shape to the great white sharks and the pelagic shortfin and longfin makos. The presence of whole fish arranged tail first in their stomachs suggests that they were fast swimmers with great agility. Most fossil shark-like fish from about 300 to 150 million years ago can be assigned to one of 2 groups. The Xenocanthida was almost exclusive to freshwater environments. By the time this group became extinct about 220 million years ago, they had spread worldwide. The other group, the Hybodonts, appeared about 320 million years ago and lived mostly in the oceans, but also in freshwater. The results of a 2014 study of the gill structure of an unusually well-preserved 325 million-year-old fossil suggested that sharks are not living fossils, but rather have evolved more extensively than previously thought over the hundreds of millions of years they have been around. It appears Selachimorpha and Betoidia split in the Triassic. Modern sharks began to appear about 100 million years ago. Fossil mackerel shark teeth date to the early Cretaceous. One of the most recently evolved families is the hammerhead shark, family Sphyrnidae, which emerged in the Eocene. The oldest white shark teeth date from 60 to 66 million years ago, around the time of the extinction of the dinosaurs. In early white shark evolution there are at least two lineages. One lineage is of white sharks with coarsely serrated teeth, and it probably gave rise to the modern great white shark, and another lineage is of white sharks with finely serrated teeth. These sharks attained gigantic proportions and include the extinct megatoothed shark, C. Megalodon. Like most extinct sharks, C. Megalodon is also primarily known from its fossil teeth and vertebrae. This giant shark reached a total length, TL, of more than 16 meters, 52 feet. C. Megalodon may have approached a maxima of 20.3 meters, 67 feet, in total length and 103 metric tons, 114 short tons, in mass. Paleontological evidence suggests that this shark was an active predator of large cetaceans. A study published in 2021 provided evidence for a major shark extinction event that occurred 19 million years ago. This is 5 million years before the established Middle Miocene disruption. The cause of this extinction event is not yet known. However, the study suggests that pelagic shark diversity decreased by over 70% and abundance by over 90%, and that modern sharks never recovered from this event. The authors also state that prior to the extinction event, sharks played a much larger role in the open ocean ecosystem than they do today. In present times, only 53 open ocean shark species remains. Sharks have keen olfactory senses, located in the short duct, which is not fused, unlike bony fish, between the anterior and posterior nasal openings, with some species able to detect as little as 1 part per million of blood in seawater. The size of the olfactory bulb varies across different shark species, with size dependent on how much a given species relies on smell or vision to find their prey. In environments with low visibility, shark species generally have larger olfactory bulbs. In reefs, where visibility is high, species of sharks from the family Carcharhinidae have smaller olfactory bulbs. Sharks found in deeper waters also have larger olfactory bulbs. Sharks have the ability to determine the direction of a given scent based on the timing of scent detection in each nostril. This is similar to the method mammals use to determine direction of sound. They are more attracted to the chemicals found in the intestines of many species, and as a result often linger near or in sewage outfalls. Some species, such as nurse sharks, have external barbels that greatly increase their ability to sense prey. Shark teeth are embedded in the gums rather than directly affixed to the jaw, and are constantly replaced throughout life. Multiple rows of replacement teeth grow in a groove on the inside of the jaw and steadily move forward in comparison to a conveyor belt. Some sharks lose 30,000 or more teeth in their lifetime. The rate of tooth replacement varies from once every 8 to 10 days to several months. In most species, teeth are replaced one at a time as opposed to the simultaneous replacement of an entire row, which is observed in the cookiecutter shark. Tooth shape depends on the shark's diet. Those that feed on mollusks and crustaceans have dense and flattened teeth used for crushing, those that feed on fish have needle-like teeth for gripping, and those that feed on larger prey such as mammals have pointed lower teeth for gripping and triangular upper teeth with serrated edges for cutting. The teeth of plankton feeders such as the basking shark are small and non-functional.